I'm going to show you how to use Google Sheets to process your experimental data, and then how to graph it in Logger Pro, and how to get error bars. So let's just use some made-up data. I'm going to copy and paste the example table that I've given you in the lab handout. And you can see that I've already done that and manipulated it here above, but I'm going to walk you through the steps that I did to get that. Everything in yellow has been changed to match my particular experiment. Again, this is a made-up experiment, but let's imagine that I'm trying to figure out how long it takes to lower a platform from a height. So the independent variable might be height, and the dependent variable is time, and I'm going to change that in all of the different places up here where it needs to be. Everything in italics and in yellow here needs to be changed. Let's say that I could I'm measuring the height in meters, and my estimated uncertainty is 0.05 meters or 5 centimeters, and my time is measured in seconds, and my uncertainty in any individual measurement of time is 0.1 seconds. Then let's say that I actually got some data, I collected some data. So I'm going to copy these heights that I measured here above. Notice that the place value in the time and the uncertainty have to match. So 2 decimal places, 2 decimal places. By the way, when this started off, it looked like this. It had one, or maybe in fact I think it had no decimal places. So let me just show you how to change that, because I want these two to match. So you highlight those, you go to Format, Number, and then if you go to More Formats and Custom Number Format, you've got all sorts of different numbers of decimal places. So if I want 2 decimal places, for example, I can choose that one. It gives me the example, and I click Apply. Again, we want the uncertainty and the value to match in decimal places. Now let me just copy and paste over this trial data. So you want to have at least 5 different values of your independent variable and 5 trials at each. So that's 25 total values. Now this column is a calculated column of the average. And to do that, you click in it and you type equals average, and then an open bracket, and you highlight everything in that row, and then close the bracket. And this 3.2 then is the average of the orange highlighted values. Okay, once you've got that, you can just get a box around it, click the blue little square at the bottom, and drag it down, and that'll give you the average of all of these. Again, if this gives you more decimal places than over here, then you're going to want to go and change that using the method that I showed you above. Now, this is the average, and we want to find the uncertainty in the average. And one way that we can do this, in a way that the IB often uses, is to use half of the range, or half the distance between the maximum value and the minimum value. So for example, if we look at this this row here, at height of 2 meters, it took 3.2 seconds, 3.3 seconds, etc. So the biggest value, the maximum value, is 3.5, and the lowest value is 3.0. So max minus min would be 3.5 minus 3.0 is 0.5, and then half of that. Now, an easy way to get this for everything using a formula is, again, type equals, then 0.5, asterisk for multiplication, maximum, and then highlight. Careful that you don't highlight the average as well, just trial 1 to trial 5. Close the brackets, minus, now min, now another open brackets, again, trial 1 to 5, and then close brackets, and then close the second brackets. Press enter, we get 0.25, and then we're going to do the same thing and drag that down. Now notice here we get different decimal place values. It's a good practice to generally round your uncertainty to 1 decimal place. You can see I've done that above. So again, with these highlighted, we go into Format, we go to Number, and then I can just choose this one. Or you can go into More Formats at the bottom. Okay, so now we've got all of our data. We've got our independent variable with the uncertainty in each value of the independent variable. We've got all of our measurements of our dependent variable, the averages, and then the uncertainty in those. Next thing we're going to do is we're going to paste this into Logger Pro. So let's highlight these, copy them, and go into Logger Pro, and paste them into our first column. Now, we don't need to worry about the fact that it's dropped the decimals, because it's still going to graph it as an exact value. Now this was height, so we're going to double click on the column, click Column Definition, type height, and the units were in meters. Okay, then we're going to go back over to the average of our time, highlight those, copy them, and then paste them in here. Okay, now we're going to call that time, and units are in seconds. And we get a graph of them. Let me resize that so it's in the screen. Now, it's given us height on the x-axis and time on the y-axis. Let's say we wanted to reverse that. So we could put height over there and time over there, like so. So now we've got height and time, and if we were to graph the slope of this, it would have units of meters over second, or the speed. Now, we don't have any error bars yet, so let's put some error bars in there. The height, we said that the uncertainty was always the same. It was always 0.05 meters. So let's double click on that, click Options, and then here go to error bar calculations, and you'll see error constant, plus or minus. We go 0.05, like that. And we get little error bars that are actually quite hard to see because they're so small. It's a little more complicated to plot our error bars in the time, because if we look here at the average of the time, we had a different uncertainty for each one. So what I want to do now is take these values and copy them and put them into a new column here. So I'm going to make this a bit bigger so you can see. I'm going to going up to data, and then I click new manual column, and I'm going to call that column error in time, and I'm going to call that to short name E, because it's time, the units are still seconds, and click done. And now I'm just going to paste those in. And so what I've got here is the average time and then the error in that time. I want to use this blue column as the error in the red column. So I'm going to go back over to the time, double click on that, and click Options, and then error bar calculations, and I want to click use column. And now I have the option to choose error in time. So if I click that, you can see now I have different width error bars, this one being a little bit bigger than this one because it's 0.5 seconds in that dimension. Okay, I can make this smaller again, and you'll be able to see the axes. Okay, so now I can click A for auto scale if I want to make this a bit bigger. And if I want to get a line of best fit, I go up here and click linear fit, and we see that I get a straight line graph that comes close to the points, doesn't hit all of them, gives me a slope that's in meters per second because my axes are in meters and seconds, and that gives me an estimate of the average speed that this thing is being raised by. Okay, so that's an example of how to use Google Sheets to manipulate your data to process it and get the average and also the uncertainty in the average as half, max, minus the min, and then also how to plot that graph in Logger Pro and how to get your error bars.